at its very nature, is a risky business, right? Anybody who tells you that every application that you write is going to be 100% successful is probably trying to sell you consulting services. At best, I think you're pretty successful as a developer if about 80% of your projects actually get used. That'd be great. I think the industry standard is about 50%. And if it's a rewrite, it's way less than that. If you're completely rewriting an existing application, you've got like a 20% chance that your application sees the light of day. So software development by its nature is risky. And I say that so that I can admit some of my failures. And in this case, I got hired by a firm, by a law firm, and they gave me my scope. They said, hey, here's the work you're going to do. And I said, oh, this project is good. I feel really good about this. I could get this done in 6 weeks. So they sit me in my office, and I start coding. And as soon as I start coding, I realized that in order for my project to get done, I had to change some things in their existing data layer. They had 20 developers on another project, and I needed to go into their code and like make some changes. And they said, no, we don't want a contractor doing that. So we want you to branch off, and we want you to start coding, right? And then when your project is completely finished, we want you to deliver it. I'm like, okay, I can do that. So I branch off, I start coding, and I code and code and code, and they're really happy with my progress. They're like, hey, good job, good job, good job. Every time I check in, good job, good job, good job, right? The time comes for me to deliver, and I'm supposed to merge my changes back in with the rest of the developers' changes. And I get maybe 150 merge conflicts. And the reason why I had so many merge conflicts is because the fixes that I was doing, they were fixing too. It just so happened that maybe they fixed it in a little bit different way, right? So what happened? Well, I would go in and try to resolve these merge conflicts, but what happens over time, and this will be a theme in this talk for the next like 45 minutes, is over time, what you lose in development is intent. You lose why you made that change, right? And all applications that go over time always ask themselves maybe, whatever period of time it is, maybe let's say it's 2 years ago. They say, hey, why'd we write it that way? And everybody looks around at each other like, I don't remember. Well, then don't change it. Don't change it because we don't know why we wrote it that way, right? Well, so at this 6-week project I'm telling you about, when it came time for me to go back and I had a conflict, I would have to go back to the original developer I was conflicting with. And I would say, hey, why did you do this? And he'd say, that was like last month. I don't remember doing that. Or, you know, I don't know why I did it that way, right? So every single time I was resolving a conflict, it was taking me somewhere between 15 minutes and an hour, right? Well, when there's 100 of them or 200 of them, that's a long time. And guess what? As I'm fixing those conflicts, more conflicts are adding up and adding up and adding up, right? So by the way, that project failed because I was blowing my deadline by a week, by 2 weeks, by 3 weeks, and it was an emergency project. That's why they hired a contractor. So at the end of it, when it was finally about ready to be delivered, they said, actually, we solved that same problem that you solved with a report, and we're doing it manually in another way with a report. So we don't need your app anymore, right? That's what happened because I blew it, right? So it really made me start thinking about, like, what did I do wrong here? And what I did wrong was I waited too long to merge. I should have been merging every day. In fact, what you'll find is if we make small changes and we push small changes to production as quickly as possible, we're actually minimizing the things that can break. And we have another way of doing that where we'll preserve intent. Okay, so keep those two things in mind. Small things are deployable, and you're decreasing the boundary of things that can change around it. And the second thing is, let's make sure that we have a way of preserving intent. If we can do that, we can make applications that are maintainable, and we can make developers have a great feeling that they're not wasting their time by, never having their project see light of day. last comment on that is small things that are deployable and get into production quickly have a much smaller chance of failing. And when they do fail, they're cheaper failures. So if I had made a data layer change and got it into production as quick as I possibly could, they could take that small change and they could approve it or deny it on its own merits. They could say, yep, that was successful, keep it in the code base, keep it in production. Nope, that was a failure, roll it back, let's have a rollback mechanism, right? So small failures are cheap failures where a 6-week failure ends up being a $30,000 or $40,000 failure. Right? A 6-month failure ends up being a $500,000 failure, right? So we want small successes, small failures. So with that, let's talk about how we can achieve that with the database. Well, first off, this is one quick other story. I've got time. So I had a customer that I'm not going to mention their name because you might know them. You do know them. And they had a leader of a software development department. And I had been consulting with them for a long time, and they said, I want to fire all of our developers. That's what he said to me. And I said, excuse me? He's like, yeah, I want to fire everybody. And I said, whoa, that came out of nowhere. Why do you want to do that? And he said, because my developers are missing every deadline. And I never know what they're delivering. I never know what's going into production. And then what often goes into production is buggy. And I feel like we're hitting the same bugs over and over and over again. So I want to fire everybody. And I said, okay, but I know your guys. Like, I've been working with your guys, and some of those guys are really, really smart. I think if you fire them, it'll be very difficult to replace them. And he said, yeah, well, my problem is I'm not technical, so I don't know which ones are good or not. That's what he said. I'm like, well, maybe you should be fired, right? Like, and he's like, okay, but here's my question. As a non-technical leader, how do I figure out who the best developers are when I can't code? And that stunned me. So I'm going to ask you that question. And then I'll keep going on as we talk about source control and continuous integration. So if you were non-technical, how would you figure out who the best employees you had were? What would you do? Probably consult with a tech league and have a technical leader you trust tell you. I think that's a good way to do it. Yeah, I think that is. Any other way? Is there like a metric-based way you could do it? That's what he was looking for, is a metric. Features delivered would be good. Yeah, so who's killing the most work items and getting them deployed, right? Somebody once said, fewest bugs, like fewest bugs assigned attributed to them, right? And my reaction to that was, actually, my experience is that the best developers create the most bugs. And one reason why they do it is just because their velocity is so fast. You know, they've got a lot of successes and a lot of failures, and they just, you know, lots of bugs go through there when you're writing a lot of code, right? The second thing is they don't really believe in any there be dragons area of the code, right? If they see something in the code that's broken, they're more likely to dive in and fix it. And complicated code creates a lot of, you know, ancillary boundary errors, right? So I went to a bunch of my developer buddies, and I asked them this question, and my business partner, Scott Reed, had a great answer for this. He said, I would tell you that the very best developers are separated from the average developers by the number of times they check into source control. That's what he said. He said, if I had to use a metric, I would go off of how many times they check in. And I said, why would you say that? And he said, because I've watched some of the greatest developers code, and they all check into source control. They're checking in all day, 3 times a day, 5 times a day, 10 times a day. And the worst developers are waiting a day, 2 days, 3 days before they check in. And I said, why do you say that, Ike? And he said, because the best engineers have a system for catching their own errors, and they rely on it, and they trust it. And so they're willing to do dangerous things because they know that they'll get caught by their system, by whatever their process is, if they make a mistake. And that system is 2 things combined. It's actually 3 things. It's source control, it's testing, and it's continuous integration. And we'll explain, if you don't know, how those three things work in tandem together. But let's hang on, I'm going to come back to that in just one second. So Martin Fowler says that great software developers are 127 times more effective than average, but only require 50% higher salary, making them the best bargain in the business. That's my favorite quote because it justifies my rate, right? Or a salary increase, right? I'm like, well, am I the best? If I am. And I think that by mixing those two stories together, your best software developers are worth the money, and they're worth the money because they rely on a system that gets them to deploy value quickly with great frequency and fewer bugs. That's what we're basically talking about today. So when Scott said, well, look, they check in a lot into source control, and that makes them valuable. I liken software development to a high wire act where you're 50 meters off the ground and you're walking across a high wire. And now, let me ask you a question. If you were walking across that high wire and you didn't have a net underneath, which meant that if you fell off that wire, you were going to die, certain death, right? How fast would you walk across that high wire? How fast? What would you do? Describe what you would do. Anybody? You'd want to get it over with. You'd go slow. I would go hand over hand, and like I might hang from the bottom, and go like an inch at a time and make sure that my grip was as firm as possible, right? So my cousin's a great software developer who is in a terrible organization, and he said, I'm lucky to write 25 lines of code a day. And I said, why is that? And he said, because my company just doesn't believe in testing. And every single time I write something, I know that I'm going to have a lot of bugs to manually figure out where they are, right? So if I told you that you're on that high wire, and not only is there a net underneath you that you enjoy, that will, one, it will 100% catch you all the time, but two, it'll put you right back up on the high wire exactly at the point that you fell off. So you've got a net underneath you that's enjoyable to land in. Now, how do you cross that high wire? Now you do cartwheels, right? You run, you do great things. And so source control is that net for us, because what it allows us to do is it allows us to make changes in the database, and if the process is good enough, know that we're not going to do anything drastic, that we're not going to lose data, that we're not going to get rid of a stored procedure that doesn't have a copy of it, right? Like, we know what we're doing. So at its core, source control is just a version control system like any type of document management system. And it just keeps the version of all of our code in a central repository. And our benefits to source control are typically that as a team, we have a communication mechanism of how code gets delivered. So I've been in organizations that have a database that's not in source control, and you know what they end up doing? They end up emailing code to each other, right? They do. I see them do it all the time. And when they email a stored procedure to each other, they'll always say something like latest version. So if you search their email and say, give me the get customer stored procedure latest version, they will have like 50 emails of that. And then they'll go through the date and time and they'll figure out which one it is, right? And now 20 minutes later, they've got it and they copy it and they put it on their local dev server, right? They're using email as the mechanism to exchange code back and forth, or they're using HipChat. But in source control, we don't need to do that because we're all using a central code repository. All I have to do is get latest and I get all of your changes, right? So we're also looking at it as a mechanism for tracking history, like how has this code changed over time, and how have we preserved intent by using source control comments. So there's a lot of different source control products out there. I don't know if the one that you're using is represented on the board, but most of us right now are using Git. But since we're in a Microsoft conference, a lot of us are using Visual Studio Online or Team Foundation Server. Now, the problem with source control in a database is that when we use source control for application files, like CS files or JS files or CSS files or whatever we're source controlling, at the end of the day, it's all just text files, right? So if we check in a text file, we can check out a text file. If we make some kind of mistake, we can go in and find the right text and copy over it or whatever. Text files are very easy to manipulate back and forth. The problem with SQL Server and all databases are that the database file that we care about is not text. It's binary, right? And you can't just put like a SQL Server MDF file under the same source control system that you'd put your CS and JS files in, right? Because somehow we got to get into SQL Server and understand what objects are in there and how they're defined and what the syntax was used to create them, right? So typically what that means is that if we're doing source control without add-ins, we are doing it by hand. We're scripting them out by hand, right? And you're relying on the developer to, when they change a stored procedure, to change it and then script it out and then check it in to whatever source control system you're using manually. And some developers will do that. Some will. Most won't. Most will say, that's a lot of hassle, and they'll avoid it if they can, right? So consequently, when people do it manually like that, and we go into source control and we say, hey, let's deploy the database from what's in the source control system, it's way out of date. It's almost always way out of date. So as a result, in order to be successful at taking these database objects and putting them in source control, you need a third-party product. And there's 3 companies right now that do it really well for SQL Server. There's Redgate, and I'll show you the Redgate tool in just a second. There's something called Apex SQL that does it really well. And then there's what they used to call Data Dude, and now they call just Visual Studio tools for the database. That's all built into Visual Studio. So those are your 3 options, and you've got to figure out which of those 3 options are really what's right for you. I'm going to describe kind of the different, oh, and there's a 4th one called ReadyRoll, which is also a Redgate product. So I'll kind of describe the differences between those 4 products, and then you can make a choice on which one you want to use. Another problem, by the way, with the database is the state issue, which is if we do this incorrectly, we could lose actual data and not actually get it recovered, right? So we've got to pay very close attention to state as we do this. So let me show you what Redgate is doing, and then, can you hear me? Yeah? All right. So let me show you what Redgate is doing, and then I'll describe what the other tools are doing without really demoing them to you. Can you guys see that? It's kind of bad. So my resolution's a little bit bad. I don't know. Do you guys recognize this tool? This is SSMS, right? And have you guys ever seen a green database before? You have, yeah. So what's happening here is this green database is using a source control add-in that is integrating SSMS with Git. I use Git right now. So right now, if I create a table, so I do new query, and I'm using this T-SQL 2012 database, and just so you can kind of read the code, let me just change my font because the resolution's messed up a little bit. So I'll just make it, 18 point or something. So if I just create table, table fill, call one int, right? So here's my new table. And I add that to T-SQL 2012. What will happen, if we get lucky, is it will tell me, hey, there's been a change to this database. And I'll get a little dot. Sometimes that takes a second, so I'm not going to wait for it. But what I can do is I can say, please commit this change to source control. And it will pull source control
and it will pull my local database, and it will diff the two of them. So this is interesting. So to show you where my Git repo is, let me just show you File Explorer. So this is my source code folder. Let's see, right here. And I've got a subfolder called Database. And in here, look at what's in here. If I double-click on tables, I have these table names.sql. And like, let me just open one of them with Notepad. Can you guys see that? Let me zoom in. If I zoom in, can you see this? What is that? That's just DDL, right? That's data definition language, right? So if I go back here to my tables, this is the DDL to create all of my tables sitting in a source code repo. Here's the DDL for all of my store procedures sitting there, right? So if I go back to SSMS, what's happening here? It took my database.
I swear this doesn't work as well. That is, okay. I took my database, and the tooling diffed my database with those DDL scripts that I just showed you, and it showed me the difference and said, this table that you just created isn't in that script folder. It's not there. Now, I told you that if the companies that do it manually, that's what they do manually. They take every object, they script it out, and they put it in a folder, and then they check it in, right? So rather than, what we're doing is we're saving that manual step of scripting it out by hand. We're just letting the tool do it for us. So in this case, I can make a comment. I can just say, adding table fill. Phil's my friend in the front row, that's why I'm picking on him.
And then I just check the change that I want to do, and I commit. And now that change is in source control. It's in that Git repo right now. And now let's pretend I'm a second developer. This is T-SQL 2012 Dev 2. And just so you know I'm not pre-baking the turkey, you don't see that table fill here, right? But I can right-click as the second developer and say, hey, just get the latest changes. And it says, hey, I noticed there's a new table in source control. Well, wait a minute. Before I do that, what happened? If we go back to tables, that table fill, at 8:54 a.m. just got added to the DDL script, right? So it said, oh, there's a script there that I don't recognize in your database, second developer. So if you want that, just pull it down and apply the changes, and it pulls down. OK, so we refresh this, and now you see table fill sitting there, ready to rock and roll, right? OK. No email, right? I didn't have to email and say, hey, is that the latest version? I know the latest version. And if I make any changes to that, I can go here, and at any point, I can see the version history if I need to. View history, right? And it will say, hey, this table's changed 5 times in the last 6 months or whatever, right? Here's how you could watch this table change, and here's who checked in those changes. So I've got just the same diff tooling that you're used to using in the other source control systems, okay? So that type of source control management, where it does an automatic compare from source control to your actual database, is called declarative source control. And that's what Apex SQL does, and that's what Redgate does, declarative. The second type of source control system is what's called migrations-based source control. So have you heard this before? This is all new. So when Phil was actually one of the earliest guys to kind of control this process, he did this by hand at one of his companies. And what they did is something that it's very popular for a lot of companies to do. But this was all a manual-based process. What would happen is, if they released a product, they said, this is 2.0, and they released it to production, right? And now we're all on a dev team together, and we're going to create 2.1, right? But we're writing it. And so I'm going to add a store procedure. So I create my store procedure, and then once I've created it, I take the script to that store procedure, and I put it in a folder called upgrade, and I put a number on it, and I say, this is 1.sql, right? And you open up 1.sql, and you see my store procedure, right? Then you go and you add a column to a table, just to add column to an alter table statement, right? And you write it, and you test it, and it works. And then you script out the add column, and you go to that same folder that you share with me, and you say 2.sql. right? And you check. Oh, they would add it to the same script, right? So as these files accumulate, 1, 2, 3, 4, all the way to 100, 150, right? Then some dev manager says it's time to release. And some poor guy has to go in there and go to every single one of those scripts and make sure there's no duplication. Because you could see the same store procedure in there 6 times, right? Because they were modifying it as they were going, right? But they weren't going to figure out if it was already in the script folder, right? They would just tack on number 98. Here's another store procedure, but it was the same one 5 times, right? And you don't want to hit the same table 5 times if you're adding columns because you'll lock the table 5 times. So you've got to go consolidate all those changes. Then you have to make sure that these scripts are safe and that they're not going to drop any data. And then you have to test them and test them and test them. And then you say, this script is good, and you cry yourself to sleep at night when it isn't, right? And then what they do is they take that compiled script and they call that upgrade to 1.0 to 1.1, right? Or upgrade 3.0 to 3.1. And then what they'll end up happening is they'll have scripts that say upgrade 3.0 to 3.1, 3.1 to 3.2, 3.2 to 3.3. And if I'm a customer that's on 3.0 and I want to go to 3.3, I run those scripts one at a time in the correct order, and I hope that my database looks the same as that dev database, because if it doesn't, I'm going to get script errors and then have to debug it. Right? Does this sound familiar to anybody? You guys have felt this pain before, right? Okay. So that migration method, that is what ReadyRoll tries to make easier for you. So ReadyRoll's job isn't to do the declarative method where it's doing script comparison. Instead, what it's doing is making those migration scripts automatically and saving them automatically and consolidating the duplicated logic for you automatically so that you can just run those scripts in a repeatable fashion. So what's the benefit of doing one or the other? Why would you do declarative or why would you do migration-based, right? In my experience, declarative is easier. If you're not doing any source control now, starting at declarative gives your project a higher chance of success. Declarative is not great in a multi-tenant environment where you've got 300 customers and they're all in various revision states, and you need to, that declarative version, it's going to be 1, too slow, and 2, too many side effects that you're not really taking advantage of. If you are in an internal development department and you've got one production server, declarative is great. You'll probably be very successful doing that. If you have 300 customers and they're all on different versions of your software, you're going to hate it. You're going to want to go to migration-based. But you know, that's just my rule of thumb. There could be other like outlier reasons to choose one or the other. By the way, this is unique in the SQL Server world. In the open source world, like Postgres and MySQL, they would never use declarative. They always use migration-based. They have very tried and true tools that have been around for a decade to help them with migration-based, and culturally, they've been doing it for a long time, and it's very mature, and it's just what all the developers do anyway, so they're not going to switch off to a different tool. So this is kind of unique on the SQL Server side that we even have this, and it's because the SQL Server developers didn't do migrations for a long time, and as a result, they were doing it manually, and guess what they were doing manually? They were using like Redgate schema compare by hand, or they were using Adept SQL, or they were using Visual Studio data, compare tools by hand. And so when the tooling came around, they just said, hey, everything that you do by hand, we're going to do automatically for you. And the SQL developers all like that felt comfortable because they knew what it was doing, right? But that's not how like the PostgreSQL guys were doing deployment already. They were using a migration-based method.
I would add that if you are in a shop where you're doing the customer upgrade for them, declarative still be a definitive way to go.
Yeah.
Start to avoid like the 9 times of alter procedure.
Yeah, that's true. Yeah, if you're doing a one-off upgrade, you know, for a customer at their site, then yeah, declarative is better. Yeah.
But like you said, even if you have the 300 customers, it's still you can save the differencing and the scripting
Yeah. Yep.
Is what we've done before too. Is basically every script within a database table, and then the user's front end can say, okay, we need 9 scripts in order to upgrade. So we just download them from our web service, put them in their database, and then it ran those scripts against the database.
Yeah. Can you guys hear Phil, by the way? Phil said, like, if you need a repeatable process, you're going to want a migration-based thing because you're handing a package off to somebody else to deploy. But if you're doing it, if you're kind of observing it and you want a quick upgrade, then declarative is better. So, okay. Yeah. So did you hear that? That's a good point. He said, don't muck with your database because if you do, our scripts will break and we can't upgrade you. That's what I like to call the SharePoint problem, right? Why are you on SharePoint 2005? Because we messed with the database and we can't get it upgraded anymore, right? Like, okay. So we're going to switch off to a new topic. Remember that high-wire act, to be caught in the net, it requires source control, testing, and continuous integration. So we're moving on to the second piece of this, which is testing. So we've been writing tests on the development side for 20 years. We've kind of matured along that. Everybody used to do unit testing, and then that kind of morphed to what they call test-driven development, which is that we write tests before we write code. And now everybody dropped all that, and they're doing what's called behavioral testing with Cucumber and Gherkin and SpecFlow. And that's pretty pervasive across software development, right? And the database developers are lagging a little bit behind. So while the rest of software development has kind of abandoned unit testing and are doing a lot more BDD and Gherkin and Cucumber testing and coded UI tests, the database developers are getting pretty good at unit testing now, which is good. Well, at least we're on the path, right? So the point of unit testing is, if we change something, we want to be able to catch a breakage in our code as early as we possibly can. So there's actually 2 points of good testing. The first point is, please catch me when I fall. When I add a bug, tell me that I've created a bug and help me fix it, right? The second thing that testing is very good at is it's very good at preserving intent to our code, because we get to name the test whatever we want to name it, right? So if my boss comes to me and says, hey, we license drivers here, and our drivers need to be at least 16 years old, right? So then I could write the code and say where birth date, is greater than date diff negative 16 years, right? I could write that in a stored procedure, and I could error out if that fails, right? But that code by itself doesn't tell me why I did it. It just tells me what it does. Code's very good at telling us what it does, but not very good at why, right? So if I write a test, I could say, please make sure all drivers in my database are at least 16 years old, and if they're not, fail per Sally. Sally came to me, she told me the business rule, and I'm going to write that right in the test, right? Now, if I ever write code where that test breaks, the test name will tell me why. It'll preserve the intent for it. So, and I'll remember the conversation. As soon as I see a little bit of intent, I'll be like, oh, I remember writing that code. Like, I remember that conversation that she said for me to do this, right? So if we look at like the software development, if we look at the delivery cycle, right? Here I write a bug, and then some period of time goes by, and I eventually get to QA testing, right? So QA testing is like the bane of our existence, right? Because that means like there's 30 testers someplace, and they're hammering our code, and they're like, your code doesn't work, right? And they say, hey, that doesn't work. They don't really say much more than that. So now the bug gets caught here, hopefully here. It would be really bad if the bug doesn't get caught here, and I deliver the code to production, and the bug gets caught by a user, right? But that is some length of time is that timeline. It could be a week, it could be a month, there's some length of time. It is far cheaper to correct bugs if we can catch it here, right? That's the least amount of money. And the reason why is because my memory is vibrant. Like, I remember writing it. I remember what I was trying to solve. I remember vaguely thinking that I was probably needed to take a look at something else, but I forgot to do that. Then the bug gets caught, and I'm like, oh, yeah, I remember. I was supposed to go look at something else. And then I go look at it. You know, is it really a bug if nobody else sees it? I don't think so. That's just writing code, right? So what allows me to identify the bug early? It's because I don't offload the responsibility of testing my software to the QA department, and I don't go through the pain of writing the test, testing things manually. Instead, I test it automatically. So this is a graph that I totally made up based on my own experiences and is not true at all. But for me, I have found that if I took the complete amount of time to correct a bug, right? Somebody created a work item and they assigned it to me. You know, Ike, your code broke. You know, don't do that, right? That bug is now assigned to me. If I took the total amount of time, I found the vast majority of my time was spent finding the bug. And a very small part was spent correcting the bug, right? So if I could make the process of finding the bug faster, then fixing bugs will be a lot less painless because I'll do them boom, 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 one right after another, right? So that's why we write unit tests. And in SQL Server, we can write unit tests for triggers, for stored procedures, and for functions. But database unit testing has some main problems. Let's see if I don't have the main problem slide. So let's just talk about, don't ignore the slide for right now. What is wrong with database unit testing? I can tell you why I hate it, and have hated it deeply in the past, and why I typically write all of my database unit tests in C#, because I found in .NET it was easier to do a few things than it was in Transact SQL, in a stored procedure. So you guys have tried to write tests. What are some problems with database testing? That's awesome. You're a great setup man. What's your name? Steven. You're a great setup. That's called testing the weather. And that's a well thought out thing, right? Like if I said, hey, look, when it's 76 degrees, I want the air conditioning to go on, right? And then I write a test for that. I have to wait around until it hits 76 degrees somehow, right? Like that might not happen for months, right? So I don't know if code that I write will break that because the weather is arbitrary to me, right? When we test in .NET, we control things a little bit more so that the environment's correct, right? But on the database, if I say, don't allow somebody to add an order unless there's a customer, right? And so I've got a test that looks for this one order that I know doesn't have a customer, and then it fires that failure when it happens. Well, what happens if somebody goes around and adds the customer, right? Now my test is broken because the data has changed out from under me. Or if I say, please warn if a customer is over their credit limit, and I write a test for that, and I aggregate all of their credits, and I do the math. Well, if another developer is fooling around and they say, oh, you know what, I'm just going to add a credit to this customer. Well, now my test is failing for no fault of my own and no bug. It's just because the weather changed, right? And I couldn't account for that. So that's one big problem, absolutely. And I'll show you the correction for that problem right now. Yep, and what else? Okay, concurrency is a big problem, right? Like if we're all running tests on a shared database server, then our tests are going to conflict with each other. Even if we're running a test builder that isn't very good, and it's running itself repeatedly over the same server, right? Now we're changing things out from under it, and we're getting errors all over the place because too many tests were running. And then the thing that irritates me the most is I like to write code in SSMS. Microsoft hates it when I tell people that, but I do. They know, by the way, that 90% of you write SQL code in SSMS. They hate it. They want you to write your SQL code in Visual Studio, but very few people do that. So if I have a test that's failing and I'm trying to get to the actual procedure that it's testing, there's no F12. So there's two things that Microsoft does very poorly in SSMS. The first one is there's no control KD. What's control KD in Visual Studio? Yeah, it's code formatting, right? So SSMS, there's no control KD, so if I have terrible code in there that somebody copied and pasted from ADO.NET someplace, and it's all one line, I can't fix it easily. It's like 20 minutes for me to fix it. And two, if I'm trying to navigate in and out of the test and when I'm testing back and forth, the navigation is difficult for me, right? I've got to like do it by hand, right? So in C#, when a test fails, you just double click on it and it takes you to what you're testing. So you can navigate with a couple keystrokes back and forth and never have a problem, right? Yeah, breakpointing's a nightmare too. Yeah, that's true too. Okay, so with that, let me tell you about an open source project that you can use right now. Actually, I think I already, there we go. So this is called T-SQL-T. Oh, we don't want that. We want this. Okay, raise your hand if you've heard of T-SQL-T. A couple of you. Okay, cool. So T-SQL-T is written by a guy from Philadelphia, Sebastian. And he is a really cool guy, kind of introverted, so he won't like go talk to you because he wants to make new friends. He just kind of keeps to himself. But if you talk to him, he will answer all of your questions for as long as you want. Like, very, very generous guy. He will answer your email. He's happy to talk about what he released for free. T-SQL-T is a testing framework for SQL Server. And it has a ton of features, way more features than we could possibly talk about in 10 minutes. But a couple of features might be interesting to you. The first feature is when you write a test using the T-SQL-T framework using debug.assert, which is kind of what we do in C#. Like, hey, I want to assert something is true. You can do that. You can insert, you can update, you can do whatever you're going to do. And at the end of your T-SQL-T test, it's an automatic rollback. So he does all the work you do, the arrange, act, assert that we typically do in testing. You do all this work. You test your results. Did it work? It worked. Roll back. And you don't have to write the rollback code yourself. It's implicit in every test you write. So that's a huge advantage right there. You don't have to worry about somebody accidentally forgetting and changing the data during their testing, right? The second feature that they have is what's called fake table, which I can say, I know this table exists in my database and there's like 500,000 records, but I don't care about those 500,000 records. I just want to interact with that table for my purposes, and so fake it for me. And so what you do is you fake the table, and the table, it renames the production one to something else. Not production, but I mean, it's a testing table, but you get the idea, right? It renames it to something else. It creates a fake for you. It allows you to interact with it. It allows you to test the results, and then it swaps everything out at the end of it for you automatically, so you don't have to write that code. So one line of code, fake this for me. Now let's play with it, right? So it's kind of a way of doing mocking with our data like we do in C# with Rhino mocks and things like that, but on the database side. Sorry about my thing here. So let me show you T-SQL-T real quick. So if I open up my query window, I have a database here that's called T-SQL-T example. And I can just do tsqlt.runAll. Okay. So if I run this thing, it runs all my tests. How does it know that I have tests to run? Well, let me go to my example and show you. I'm going to show you some store procedures. And I'm going to zoom in on this real quick. So can you see that okay? Can you see the schema? That's what I want you to see is the schema here. In T-SQL-T, you have 3 different schemas. You have the schema of production code, right? Or whatever. How many schemas is that? I don't know. You guys use 5 schemas for production code? 10 schemas? So you've got all the schemas for production code. That's the stuff that you're writing, right? Then you have a schema that you reserve as just your tests. So you could call it my testing schema for all I care, but name it whatever you want. But that's the schema all your tests are going to be in. Why are you putting all of your tests in its own schema? Well, one, your tests are going to balloon up if you start doing this properly, and you're going to want to filter them out as you're actually looking for real code, right? You're not going to want to elevate those to production, right? You're not going to want the testing to go everywhere, right? So you put it in its own schema so that you can filter it out in your deployment cycle. And then the third schema that you have is the T-SQL-T schema, and that's its own schema that it uses for fake table and debug.assert and all that stuff. That's the schema you're seeing here. So in my case, I have an accelerator schema that has business logic in it. And then I have an accelerator test schema. That's all my test code. And then just the standard T-SQL-T schema where you could see, assert like. Hey, that's nice. We don't have that in C#. Assert like with wildcard operators, right? Assert not equal to, assert string in, right? OK. So I ran T-SQL-T run all, and it responded, and I'll zoom in, with, hey, 11 test cases were executed, 10 succeeded, and 1 failed. And if I click on accelerator tests, tests ready for experimentation of 2 particles, and if I click over here, error, right? That's the one that failed. So, OK, I can go look for that test, right? I know that that test is test ready for experimentation of 2 particles. And if I go in here, I can scan down and say, test ready, it's this one, right? And I can right-click and modify it like you would normally, right? And then you see, oh, there's fake table. I told you about that already. And then it's doing this thing, is experiment ready, and I can now then go find that thing, right? See the pain? Do you see the pain of code navigation? Like, that's not super great, is it? Now, Redgate has a tool, by the way, called SQL Test. But Visual Studio also has its own testing that's not that bad that will help you with navigation also. So if you're writing code in Visual Studio, you'll use Visual Studio Test, MS Test, and database projects. If you're using SQL Server Management Studio, Microsoft doesn't have a plugin for SSMS right now. So you'll have to use the Redgate tooling if you want these features. So if I click on SQL Test, let me zoom in here. This is the Redgate product. Does that, though, if you're a C# developer, does that look familiar to you? It probably looks like InUnit or, MS Test. They all kind of look the same, where they say, hey, you want to run all of the tests, or do you just want to run one test at a time? And in this case, it's just a graphical overlay of the text that you just saw, right? So I've got that same failure, but now look at the difference. So if I right-click and I run the single test and it fails, I can just double-click it, and it brings that test up. And then as part of, this is the thing that's failing, as part of Redgate SQL prompt, you can right-click and script object as alter. That F12, go to definition in Visual Studio. F12 here, go to definition, right? Same. So I script it, I open it up, and I see, oh, it's giving me 2 particles, but it's checking for 3. That comparison operators get you every time, right? Test the boundaries, right? So I put an equal sign there. I execute my new store procedure. I go back to SQL Test. I right-click, I run that test, and now it's green, right? So remember, I said most of my time is spent in finding the bug. And if I could get the finding part down, I'd be a better developer, right? I'd be the difference between an average developer and a great developer, wouldn't I? Because I rely on my process to catch me when I fall. Testing is part of that process. That's part of what we're trying to do. We're trying to, that test, one, does that preserve intent? Does that tell me why I'm testing something? Yep. And 2, it leads me to the code I broke. And you saw how I followed the path and got led directly to where the bug was so that I could fix it, right? OK. That's testing. You guys learning something? You guys like this? Okay, good. So, uh-oh, where are my slides? Some general testing wrap-up. It's standard in all unit testing to do the AAA method of unit testing. This is not a Microsoft thing or a Redgate thing or a SQL thing. This is across the board, all developers do this when they write unit tests, and they've been doing it for 10, 15 years. It's called arrange, act, and assert. And arrange is like your setup. You saw me arrange with fake table in my test, right? And then act is call some code, right? And you saw me call is experiment ready. And then the final phase is assert that something is true. And if you look back at my code, you can see this T=T assert equals string. Look, I want this string, I want the status message to be this string, right? That's me. So here's the arrange. Hey, insert a couple things into a table. Here's the act, get the status message. And here's the assert, that status message better be this when there's 3 particles, right? So it documents code functionality like we talked about, better than commenting code, and it allows refactoring. Meaning, if I change code that's currently under test and the test breaks, now I know what I did wrong, right? We can skip all that. Remember that story of the guy came to me and said, I want to fire all of my developers? And he listed off a bunch of complaints, and one of the complaints was, why does the same bug keep appearing over and over again? Say, they know they're going to break it. Just don't break it anymore, right? Our users don't trust us because they think our software is super buggy, right? And then he also said, like, I feel like the whole platform is terribly unstable. Guess how much testing that company was doing? Zero testing. So, you know, maybe what I know everybody knows what they're supposed to be doing. It just sometimes requires a little bit of a reminder to, like, you know, it's like when my mom tells me not to swear so much. Like, I know I'm supposed to not swear, but I forget. Sorry. Okay. Microsoft has this thing called code analysis. They used to call it FXCop. But you can run code analysis against C# and it will tell you how terrible of a developer you are. And it will say, you know you're not supposed to do that. Why are you doing that, right? And then you go fix it. Well, there's an open source project called SQL that's like FXCop, but it's for SQL, and it does things. I'm going to tell you one that I see all the time, but I know you guys see it. Don't fix it. They say, hey, you're not supposed to put functions on the left side of the equal sign, particularly in a join operator, right? You know that. Why? Because you have a tendency to scan when you do that, right? You know that doesn't scale when you do stuff like that. Like, don't put those functions on the equal sign when you're joining. You're going to scan those tables, right? And yet, SQL Cop will tell you that in 2 seconds. Hey, I see you doing that. Don't do that anymore, right? And then you go in and fix it. So the reason why I mention that is it's part of the Redgate testing tool. So if I come back here, it is. It's supposed to be because they're under an agreement. Yep. So if I come in here and I say, under SQL test, I want to add a new database, and I just want like this Redgate or this partition, this database to be tested, and I click OK. It goes and it adds a bunch of stuff, but one of the things that it adds, so if I go up to partition this, and I look at all of my stored procedures, you'll see a bunch of SQL, like test columns with float data type, right? Column collation does not match database default, right? We know we're not supposed to do it. Sometimes it slips through, right? So what this does is it adds these like best practice tests to your test framework and warns you when you mess up. Like now you have to specifically ignore it Like, I know I did that there, but I don't have an alternative. Or you have to like go fix it before your developer friends embarrass you at lunch, right? Public humiliation has made me a great developer. So, okay. Yeah, that's right. I did. Yeah, thanks. Okay. So in testing best practices, these are some of the most common mistakes I see when other organizations implement testing for the first time. The first mistake I didn't even put there, but I'm going to say it very clearly. Not all tests are all that great. So what I see, the biggest mistake I see developers make when they write tests is they're afraid to throw out bad tests. But like I often go in, I'm like, why is testing taking 30 minutes? And I'll see the same thing tested 5 different times the same way. Because each developer decided to test the same functionality because they didn't want to break it. I'm like, well, we don't need that. I delete 4 of them and keep 1 of them, right? Or what will often happen in writing a new project is they will test to learn because they don't know. So they'll write a bunch of tests to get their minds wrapped around what they didn't know. But then once they know it, they keep the learning tests in when really they've got another test that's more succinct, faster. So I'm like, you can obviously see them. You're like, you didn't know what you were doing here. You wrote a bunch of tests with terrible names. Like, let's delete all these, right? So if you're committed to testing, you feel comfortable deleting stuff. You're fine deleting it, right? Because you know the other tests will catch you when you fall, right? Long names with spaces. You don't need to follow C# naming conventions when you write tests. You could say, Phil told me my code sucked on Thursday, so I decided to write this test to fix this one bug he told. You could say as much as you want because you're never going to call that. You don't directly call these methods by hand. Your test harness calls it. So you can, we don't add spaces in SQL because nobody likes square brackets. And they yell at us. We don't want to type. Why do you make me type, Ike? Right? But in testing, nobody writes that by hand, right? They don't call it. They let the test harness call it. So feel free to long spaces, cleared, no abbreviations in tests. That's a big problem. If I see abbreviations as a consultant, I'm like, I don't know what ADDP means. What are you doing here? Nobody knows, right? Oh, I'm testing ADDP. Only you know what that is. Anyway. Test small chunks. If your tests are really, really long, you're testing too much. This is very controversial, but test coverage is overrated. So a lot of development managers will sit up in front and say, my project is 95% covered in tests. 95%, that's a lot of wasted time. Like 95% of your code is probably, crud stuff. Like who cares, right? So I think do you know what test covering means? Test covering is a tool that you can run, and it will watch how many lines of your code is tested, and it will tell you what coverage you had on that test. And really, I think a good coverage is between 40 and 50%. So if you're there, I think you guys are great. If you're lower than 40, you probably aren't writing enough tests. If you're higher than 60 or 70, you're probably writing way too many and wasting a lot of time. And then not all spructs are testable. Like stored procedures that return 5 results, and they have a lot of external references to, anytime a stored procedure creates a table that's not a temp table, does something with it and drops it, or my favorite, drops it at the beginning and then creates it, because what they're doing is creating side effects, right? And those side effects are a test nightmare. So, and they're a concurrency nightmare. There's a whole bunch of nightmares involved with that. So just be aware when writing procedures that if you commit to testing, not only will your procedures be testable and under test, but they'll actually be better procedures. They'll be more central concern, one focus of concern. Yeah. Yeah. That's a great point. That's a great point. So thanks for that. I'm running over. You guys. So I have like a whole bunch of slides left, but we got, an hour's too short. This is like a 90-minute talk. I did want to talk about one more thing, and I know the next speaker wants to get up here and prep, but just 3 minutes. The most important thing on the database side is continuous integration. But you have to do it in order. Once you do source control, once you do testing, you need to add it to a CI environment. What is a CI environment? Continuous integration is just an automatic script runner. That's all it is. So if your testing is good, continuous integration can check out all of your code from source control. It can try to build it, and you're thinking, why would you build a database? It's because databases do late binding. Late binding means that you probably have stored procedures out there that won't even run because the tables that they're relying on are not even in the database, right? That late binding mechanism allows us to get rid of dependencies without knowing about it. So the build process will test all the bindings, and that's really important. Then it will run all of your tests automatically. And if all your tests pass, it will automatically do that declarative method of deployment. Remember the declarative method of source control? It will do that same method to get it into a new database in a test environment where UAT can come along, like users can come and approve something before it goes to production. If you do those three things, source control, testing, and automatically run those tests and automatically get it into a test environment for users, you will deliver faster. You will deliver more frequently. And when you deliver faster more frequently, do you remember all the way back at the beginning what happened? All the way at the beginning I said, small things have a limited boundary of errors, and they're easier to succeed, and they're easier to roll back, but they're more likely to succeed, right? So if we can start deploying more frequently, more automatically, we are going to have more successes and cheaper failures, and that's the whole purpose of this, right? So that's a CI environment. Now, for my CI environment, I use Team City. And here's Team City. And while we were talking, Team City, remember when I wrote that table fill? Remember when I wrote that? I checked it in to Git. Team City detected that check-in. It downloaded it. It built it. It ran all of my tests, and it deployed it automatically. And how do I know that? Because I have a database that's not under source control. It's this T-SQL 2012 integrated test environment. And if I open it up and I right-click it and I refresh, uh-oh. I thought I would see it. Do you see the fill table? Uh-oh. Well, but this should have ran automatically, and I don't know why it didn't. No, it's targeting integrated. I'll just run it by hand real quick. So that was going to be way more impressive. But what will happen is my CI environment will automatically take that table that I built earlier, and it will put it into that database and ready for users to play with and get on. So the more automated things are, the more we'll deploy. And I hope you guys have recommitted yourselves to doing what I know you should do. I know you should do it. You know you should do it. Use source control frequently. Write those tests. And script deployment as much as possible so that we can do it every day. That'd be great if we could do it every day. Thanks very much for your time, guys. Thanks. I use Team City, but I've used